Hello again, welcome to another lesson in geometry. Today we are covering section 3.2, properties of parallel lines. Okay. All right, so quick review. Circle the symbol for congruent. So remember, congruent is saying that two shapes are the same in some way. So the segments could have the same length, or angles could have the same degree measure. And we do that with the equals with a little squiggly on top of the equals. Okay. Identify each angle below as acute, obtuse, or right. So a right angle is a measure of 90 degrees. An acute angle is an acute small angle, less than 90. And obtuse angle is bigger than 90. Okay. Interior. So we talked about interior last time. The interior is the inside of a figure. So the interior of two lines is this stuff that lies between the two lines. The interior of a triangle would be the part inside the three sides, so forth. Okay. Use this vocabulary. So use the diagram at the right for exercises 5 and 6. Underline the correct point to circle each sentence. And be careful here. We do have to have a point at A and a point at C. Okay. So the interior of the circle contains point A only. Okay. So A is on the interior, B is on the circle, I'm sorry, C is on the circle, and B is in the exterior of the circle. Okay, so on the circle is neither interior or exterior. All right, the interior of the angle contains points A, B, or C. So A is the vertex of the angle, that's on it. C is on the angle, but B is in the interior of the angle. It's between the two sides of the angle. All right. Underline the correct word to complete the sentence. The endpoint of an angle is called the vertex. So where the two rays meet, we get the vertex. So in this case, point A is the vertex of angle A. Okay. Write two other ways to name angle ABC in the diagram here. Okay, so here's different angle ABC. There are three other ways to name it, so we'll write all three. So this is angle 1 is one way. Angle B is another way, and the other name is CBA. Okay, remember, you always have to have the vertex in the middle, but it doesn't matter in what order you put the other 2 points. Okay, on our second page, we have a postulate, which is something that we just have to agree is true, and then 3 theorems that we can prove true based on that postulate. All right, so our postulate is that corresponding angles postulate, and it says if a transversal intersects 2 parallel lines, then the corresponding angles are congruent. So here's a picture of it. Here's 2 parallel lines. Here's our transversal cutting across it. And corresponding angles 1 and 2 here are going to be congruent to each other. Okay, and this will always be the case. So they'll always have the same measure. And we'll use and prove this, or we'll show this with some patty paper in class next time. All right, so once we know this postulate, we all agree it's true, you can prove these other 3, which is a transversal intersects 2 parallel lines, then alternate interior angles are also congruent. And same side interior angles are supplementary. This means they add up to 180, okay? And alternate exterior angles are congruent. So we have 3 theorems that we can be proved using this postulate, okay? All right, so use the graphic organizer in the diagram to find each congruent angle. So based on postulate 3.1, which was corresponding angles postulate, so corresponding angles are congruent. Then angle 3, which is in the bottom left, should be congruent to angle 1. That means they should have the same measure. And then using theorem 3.1, the alternate interior angles theorem, we should be able to show that 3 and 7 are congruent. They're alternate interior. And then using theorem 3.1, the alternate exterior angle should be congruent. So 1 and 5 should be congruent to each other because those are alternate exterior. All right. Problem number 1, identifying congruent angles. So one way to justify measure of angle 5 is equal to measure of angle 55 is shown below. Okay, so let's go through it. Measure of angle 1 is equal to 55 by the vertical angles theorem. So they say 1 and 55 are the same, vertical angles. And then measure of angle 5 is equal to 55 by the corresponding angles postulate because angle 1 and angle 5 are corresponding angles. So 1 and 5 are corresponding, so they're going to be congruent. And so let's see if we can do this a different way. Write a reason here. And measure of angle 7 is equal to the measure of angle 55. So the measure of angles 7 and 55 are the same. So 7 and 55 are going to be the same because these are corresponding angles are congruent. And this only works, remember, if the lines are parallel, okay? And then 5 and 7. 5 and 7 are going to be the same because these are vertical angles. Okay, so this is going to be vertical angles are congruent. Okay, and then 5 and 55 will be the same. Let's take a look at this. So we could do two ways for this. We could say substitution. So you can replace 7 with the answer to 7. So we can put 55 here. Or we could use transitive property of equality, because here we have, let's see, A is equal to B, and B is equal to C. So therefore, I know that A and C are the same. So this is A and this is C. So I'm going to use the transitive property of equality. Okay, on our third page, we have two problems here dealing with proofs. So we want to prove an angle relationship, and our given here is lines A and B are parallel, and we want to prove that angle 1 and angle 7 are the same. Okay. All right, so the given, that's our first reason here in our statement. So the given is A is parallel to B. All right, our second reason are if lines are parallel, then corresponding angles are congruent. So which ones are corresponding? Well, angle 1 and angle 5 are corresponding. Okay, they're both in the top left. So angle 1 is congruent to angle 5. Then congruent angles have equal measures. So we're going to take this from talking about angles to talking about numbers. So the measure of angle 1 is equal to the measure of angle 5. All right, then we know something else. We know that vertical angles are always the same. We've learned that before. So we're going to look at 5 and 7. Those are the only pair of vertical angles that are marked here. So angle 5 is congruent to angle 7 because vertical angles are congruent. Okay, and then congruent angles have equal measure. Well, we're just going to change these to numbers again. So the measure of angle 5 is equal to the measure of angle 7. And then we're using the transitive property of equality here. So if we look at statements number 3 and statements number 5, you could see in statement number 3 we have A is equal to B, and in statement 5 we have the same conclusion for its hypothesis, so B is equal to C. And that means that A should be equal to C. So the measure of angle 1 is equal to the measure of angle 7. Now, since these two are equal measure, they also must be congruent angles, and this is what we are trying to prove. So angle 1 is congruent to angle 7. All right, so the last step of your proof should always be the proof part. So we're trying to get statements in here that match and get us down to what we were trying to prove. Okay. All right, second one's a bit harder. This time we're given all the statements, but we have to come up with the reasons. So find the measure of angle 1, and we have to justify our answer. So there are two sets of parallel lines, and each parallel line also acts as a transversal in the picture. Okay. So L is a transversal for P and Q, and M is a transversal for P and Q, but P is a transversal for L and M, and so is Q. Okay, so they can all be each other's transversals. All right, so angle 1 is congruent to angle 4. Okay, so here's angle 1, and here's angle 4. Those are alternate interior angles, so we can use the alternate interior angles theorem. And you can call it by its name, or you can give the description. So if parallel lines are cut by a transversal, then alternate interior angles are congruent. Okay, either way is fine with me. Okay. This name, alternate interior angles theorem, is very common. You'll see it for all books across geometry. All right, so the measure of angle 1 is equal to the measure of angle 4. Well, that's what we were doing above. That's just congruent angles have same measure. So we're taking angles and turning it into numbers here. So congruent angles have same measure. Okay. Angle 4 and angle 6 are supplementary. So angle 4 and 6, let's look at where they are in our picture. So there is a line, and then 4 and 6 are right next to each other on the line. So these are form a linear pair. So this is our linear pair postulate, which just says linear pairs are supplementary. Okay. Angle 4 and 6 are equal to 180. Well, that's the definition of supplementary. So since we know they're supplementary, we can write them as a sum. So this is the definition of supplementary. Two angles are supplementary, then they add up to 180, or if two angles add up to 180, they're supplementary. Okay. Now, angle 1 and angle 6 add up to 180. Now, where does that come from? 1 and 6 are nowhere close to each other. Okay. So they're not same side interior, so they don't add up to 180. But what we do is we take, let's see, this statement 2 and statement 4 and put them together. And you can see that 1 is the same as 4. Therefore, I should be able to do a substitution and replace 4 with 1 in that statement. So this is the substitution property. So where angle 4 was, the measure of angle 4, I replace it with the measure of angle 1, and that's because the measure of angle 1 and angle 4 are equal to each other. All right. Then we get measure of angle 5 is 105. All right, that one comes from our picture again. So 5 and 105 are the same, and that's because corresponding angles are congruent if the lines are parallel. So that's our corresponding angles theorem. Okay. And then the measure of angle 6 is 105. Now, measure of angle 6 is 105. Let's take a look at 6 and 105. So here's 6, and here's 105. They're in the interior of these two lines, and they're on alternate sides. So this is our alternate interior angles have the same measure. Okay, so alternate interior angles theorem, again. Okay, and then we have the measure of angle 1 plus the 105 is equal to 180. So we're going to take this statement that we had for 5, 1 plus 6 is 180, and then we're going to substitute into that statement 7 and replace 6 with 105. So this is our substitution property again. Okay, and then lastly, okay, we just subtract 105 to both sides. So this is the subtraction property of equality. All right, so that concludes our first two long geometry proofs. We did some algebra proofs before. So this is a little bit trickier, looking back and remembering all these definitions and postulates and things. All right, so problem 4, using algebra to find an angle measure. In the figure at the right, what are the values of x and y? So the bases of trapezoid are parallel. So trapezoid definition has one set of parallel lines, and you can see those little red marks here and here to show that they're parallel. Okay. Use the same side interior angles theorem to complete each statement. So here's a transversal cutting across my blue parallel lines. Then the same side interior should be supplementary angles. So 2x plus x minus 12 equals 180. And then the same thing happens over here. This guy cuts across, so 3y plus 20 should be equal to 180. And then we're just asked to solve each equation. So this will become 3x minus 12 is 180. And then we add 12 to both sides, so we get 192. And then I divide by 3 to both of them, and 192 divided by 3, I'm going to pull out the old calculator here just to make sure I don't mess it up. I get 64. So x is 64. If you plug that back into our equation, so our expression's up here, 2 times 64 would give us an angle of 128 right here. And 64 minus 12 would give us an angle of 52. And if you add them together, they do make 180. So we know we did the problem right. Okay. In our second one here, we have 4y plus 20 equals 180. Subtract 20 to both sides, so 4y is 160. And then divide by 4 to both sides, which means y is 40. So this one is 120, and this one is 60. Those two add up to 180 also, and they should because they're same side interior, which are supposed to be supplementary. All right, pause your video here as usual, do the lesson check yourself, and then come back and take a look at it. All right, welcome back. In the diagram at the right, angles 1 and 8 are supplementary. What is a good name for this pair of angles? Okay, so angles 1 and 8 are supplementary. Circle the best name for lines A and B. Well, lines A and B are parallel. Circle the best name from the list for angles 1 and 8. Okay, well, they're on the same side. So I would say they're not alternate. That's not good. They're definitely not congruent. One's really big and one's small. They're not corresponding because 1 and 5 would be corresponding. So same side's the only thing they are. Circle the best name from the list for angles 1 and 8. Let's see, they're both exterior. They're outside of AB. So the interior is in here. So they're exterior. And use your answers to exercise 20 and 21 to make a name for angles 1 and 8. So I'm going to call these same side exterior. Okay. And same side exterior are also going to be supplementary. Okay. All right. Math success here. So check off the vocabulary words that you understand. Hopefully you know what alternate interior angles are and what alternate exterior angles are. And you should be able to prove some angle relationships. How are you on this meter? So ideally we want to be up here. If not, you might want to go back to page 3 and look through that proof again and make sure that you study some of those definitions and postulates and theorems so that you can use them in your proofs. Okay, I'll see you next time in class.